Hey everybody, it's Miss C, 4th grade teacher at Syracuse Academy of Science and Citizenship Charter School. Today we are going to be talking about the wind as we continue our lesson on weather. So previously we learned about erosion, we learned about precipitation, we learned about drought. Now we know that the weather happens in the atmosphere, and a lot of things go on in the atmosphere that contribute to the changing weather. And the wind is one of them. So we're going to talk about the wind today. So we're on page 264 in your Fusion book, and we're going to begin reading together. When the wind blows, a gentle wind can be pleasant, cooling you off when it's hot outside. However, a windstorm can cause damage. What causes wind to blow? The sun warms Earth's surface unevenly. This uneven heating causes differences in air pressure. Air moves away from areas of higher pressure to areas of lower pressure, similar to how water flows downhill. This movement of air is called wind. Areas near Earth's poles receive less sunlight than areas near the tropics. At the poles, the air is cold and has higher pressure. As a result, air moves along Earth's surface from the poles towards the tropics. At the tropics, air warms, rises, and moves towards the poles. These winds, called global winds, blow over large areas of Earth. They move large weather systems, such as hurricanes. Local differences in temperature can also cause wind. Earth's surface heats up at different rates. For example, the side of a mountain heats up more quickly than the valley below. As a result, a valley wind forms as air moves from the valley up the side of the mountain. This is an example of a local wind. Now over here we have a really cool tool that scientists called meteorologists who study the weather use, and it is called an anemometer. An anemometer measures wind speed. So wind pushes against the cups on the anemometer right here, and this causes it to spin. The rate at which the cups spin is measured and used to determine the wind speed. So as these spin, the anemometer will measure how fast they're going. And based on how fast this is spinning, that is how we know how fast the wind is traveling or how fast the wind is blowing, which is called the wind speed. A wind vane points in the directions from which the wind blows. Now here at the bottom of our anemometer, so the anemometer is right here, and these are the cups that would spin in the wind. Right here is the wind vane. Now what do you think these letters stand for? N-E-W-S. North, south, east, and west. So these are our directions, like on a compass. And right here, this will also spin, and this is part of the wind vane. So this is a 2-in-1 gadget right here. It's an anemometer and a wind vane. You can also have these separate. Now, as the wind blows, not only will it push these cups, which we can see how fast the wind speed is, it will also push this little guy right here. And whichever way it ends up pointing, so here it's pointing in between north and east. We know that the wind is either moving at a certain speed based on our anemometer, but now we know its direction. So a wind vane tells us direction, and an anemometer tells us wind speed. So we are going to do a fun experiment next Friday, and we are going to make our own wind vane. So stay tuned for that, for our fun Friday experiments. All right, we're moving on to our next page. So we're on page 265. Local winds move short distances and can change direction. Daily changes in temperatures can cause local winds to change direction. For example, at night, the mountainside cools quicker than the valley below. The wind at night blows from the mountainside to the valley floor. In coastal areas, daily temperature changes results in local winds known as land breezes and sea breezes. Now we have our two pictures here. We have an example of a sea breeze, an example of a land breeze. So our sea breeze happens during the day. The land heats up more quickly than water. Air over the land also warms, causing the air pressure to drop. So we have high temperatures with low air pressure. Cooler air flows from over the water to the land, forming a sea breeze. Now, with our land breeze, this happens at night. And what causes it is at night, the land loses heat more quickly than the water. So over here, it's going to be warmer than it is over here. And as the air over the land cools up here, the air pressure rises. So we know with colder temperatures, we have higher air pressure. As the air pressure rises, cooler, high pressure air flows from the land towards the sea, forming a land breeze. So our sea breeze is formed from the land heat, and that means that there is lower pressure over here and higher pressure and cooler temperatures over the water. So the cooler and higher pressure air will flow from the water towards the land, causing the sea breeze.